Hello everyone, welcome to lecture 19. This is on section 7.2, which is on right triangle trigonometry. So let me start by introducing the different trigonometric functions. So we have a right triangle. So this is the right angle, right? 90-degree angle. Let's say this is my angle theta. And my sides are, I'll call this A, one leg B, and the hypotenuse C. So relative to that angle theta, A is the adjacent side. B is opposite. And then C is the hypotenuse. So the hypotenuse is always the longest side or the side opposite the right angle. Okay, so the sine of theta is defined to be the length of the opposite side over the hypotenuse. So in this case, right, the side opposite is B, hypotenuse is C. So it's B over C, that ratio. The cosine of theta is defined to be the length of the adjacent side over the hypotenuse. So in this case, that would be length A over C. And then the tangent of theta is defined to be the length of the opposite side over the adjacent side. So in this case, it would be B over A. Now, when these words are written out, sine, cosine, and tangent, sine is actually S-I-N-E, but we abbreviate S-I-N. Cosine is C-O-S-I-N-E, and tangent is T-A-N-G-E-N-T. Okay, but they're abbreviated S-I-N, C-O-S, and T-A-N. All right, now how do we remember this? Well, there's a nice mnemonic that you might know. It's called SOHCAHTOA. I use this all the time myself. I think it's worth remembering if you don't already know this. And it just helps you remember those relationships, right? So this says that the sine, right, the SO says the sine is opposite over hypotenuse, right, OH. Cosine is adjacent over hypotenuse, AH, and then tangent is opposite over adjacent. And then we have what are called like the reciprocal functions. There's three more. The cosecant of theta, but that's simply 1 over sine of theta. So remember, if sine was B over C, then 1 over sine is going to be C over B, right? We flip it. And then we have secant of theta. Well, that's 1 over cosine of theta. But cosine is A over C, so this is going to be C over A. And then finally, cotangent of theta is 1 over tangent. And since tangent is B over A, this is going to be A over B. And if I write these names out in full, so this is cosecant, then secant, and then cotangent. But again, they're abbreviated CSC, SEC, and COT. Okay, so it's really important to recognize like what angle you're dealing with and what side is adjacent, what side is opposite. So it depends on how the triangle is drawn. Let me draw it like this. Right, because the right triangle can be oriented any different way. Let's say it's oriented like this. So this is my right angle. I'll call this angle alpha and this angle beta. So this side right here, first of all, the longest side, the side opposite the right angle, this is the hypotenuse. Right? It's always the hypotenuse. This side, since it's next to the angle alpha, this is the side adjacent to alpha, but it's opposite angle B, so this would be opposite beta. And then this side is next to beta, so it's adjacent to beta, but it's opposite alpha, right? Opposite the angle alpha. Okay, so for example, let's say you're given this right triangle. Let's say this is length 3, this is 4, this is 5, and you're told this is alpha, and this angle is beta. So what we want to find is we want to find all the trig functions of alpha and all the trig functions of beta. Right? So I want to find sine of alpha, cosine of alpha, tan of alpha, and then cosecant of alpha, secant of alpha, and then cotangent of alpha. And then later I want to find sine of beta, cosine of beta, tan of beta, cosecant of beta, secant of beta, and then cotangent of beta. Okay, so let's start with alpha. So relative to the angle alpha, right, we want sine. So we want opposite and then over hypotenuse, right? So sine of alpha is simply going to be opposite, which is 4, over hypotenuse, which is 5. Cosine is adjacent, so what's next to the alpha? It's the 3 adjacent over hypotenuse, right? So that's going to be 3/5. Tangent of alpha is opposite over adjacent, so opposite is 4, adjacent is 3, so 4/3. And in cosecant, remember, is the same as 1 over sine of alpha. So if sine of alpha is 4/5, this is going to flip, right? This will be 5/4. Then secant is 1 over cosine of alpha. So if cosine was 3/5, then this is going to be 5/3, right? It'll be the reciprocal. And then cotangent of alpha is the same as 1 over tan of alpha. So if tan was originally 4/3, this is going to be 3/4. Okay, and then now I want to do betas. So relative to the angle beta, the 3 is opposite, the 5 is the hypotenuse. So this is the sine of beta is going to be 3/5, right? Opposite over hypotenuse. Cosine will be adjacent, so that's 4/5. Tangent is opposite over adjacent, so 3/4. Cosecant is same as 1 over sine, so it flips, so that'll be 5/3. Secant is 1 over cosine, so that'll be 5/4. And then cotangent is 1 over tangent, so that would be 4/3. Okay. And notice here, right, notice that sine of alpha is the same as cosine of beta. And tan of alpha is the same as cotangent of beta. And secant of alpha is the same as cosecant of beta. Right? What's the relationship between alpha and beta? If you look at this, right? Remember, all the angles of a triangle add up to 180 degrees. We already have one angle, the right angle, which is 90 degrees. So alpha and beta, they have to add up to 90, right? So the relationship is where alpha plus beta is equal to 90 degrees. Or if we're in radians, then alpha plus beta is equal to pi over 2 radians. Okay, well, these are called, there is a reason why this is true, and they're called cofunction identities. Let me do that on the next page. So cofunction identities. So it turns out that sine of theta is going to be equal to the cosine of 90 minus theta, right? Or I'll write it in radians as pi over 2 minus theta. Then cosine of theta is sine of pi over 2 minus theta. Then tangent of theta is cotangent of pi over 2 minus theta. Cosecant of theta is the same as secant of pi over 2 minus theta. Secant of theta is cosecant of pi over 2 minus theta. And finally, cotangent of theta is the same as tangent of pi over 2 minus theta. Right? So there, if you recognize here, we have sine and we have cosine, then tangent, cotangent, right? Secant, cosecant. So if you have a right triangle, and one angle is, in this case, theta, then the other angle has to be pi over 2 minus theta. Right? So sine of theta is the same as cosine of this other angle, which is pi over 2 minus theta, or 90 degrees minus theta, right? if you're working in degrees. So one simple example is this, right? Let's say I have, if sine of alpha is equal to 7/12. Let's say we want to find cosine of pi over 2 minus alpha. Well, since they're cofunctions, right, then we know that sine of alpha is equal to cosine of pi over 2 minus alpha. So in this case, cosine of pi over 2 minus alpha has to also be equal to 7/12. Right, because they're cofunctions. Okay, here, let's do an example. Let's say I have, I'll just on the next page. Okay, so let's say that we're given this triangle. And it's a right triangle. And this length, I'll call that A, that side A, this side B. The hypotenuse is typically called C. And the angle that's opposite the side little a, we'll call capital A. So that's angle A, and then this is capital B. And let's say we're told little a is equal to 9, and B is equal to 2. And from that, we want to find the sine of angle A, cosine of angle A, tangent of angle A, cosecant of angle A, secant of angle A, and then cotangent of angle A. Okay, so how do I find sine? Well, sine of angle A, sine is always going to be opposite over hypotenuse. So in this case, the opposite is little a, hypotenuse is C, right? So this will be, well, first of all, we don't know what C is yet, right? But we can figure out C by Pythagorean theorem. So let me start with that. So find C. We know A and B. So find C using the Pythagorean theorem. So we know in general that a squared plus b squared is equal to c squared. So c has got to be the square root of a squared plus b squared. And we're going to take the positive square root, right? So in this case, this is equal to square root of 9 squared plus 2 squared. So what's that? Square root of 85. And then let's approximate it. So if we plug that into a calculator, it's approximately 9.22. If you want an exact answer, you'd have to use the square root of 85, but we'll just do an approximate answer. So 9.22. So sine of angle A is going to be the length of the opposite side, which is 9, divided by the length of the hypotenuse, which we just found is 9.22. And this is approximately equal to 0.976. Okay, then cosine of angle A. Well, cosine is going to be adjacent over hypotenuse, so that's b over c. So in this case, it's 2 divided by 9.22, and that's equal to around 0.217. Then tan of angle A, well, that's going to be opposite over adjacent, right? TOA, so a over b. So that would be 9 over 2, which is what, 4.5. Then I have cosecant of angle A. Well, that's the same as 1 over sine, right, of angle A. So that's really just c over A. So I can write that as 9.22 over 9. And that's equal to around 1.025. Then secant of angle A is the same as 1 over cosine. So that's going to be c over b. Right, so really it'll be 9.22 over 2. And that's equal to around 4.61. The other way you could do this, you could say it's 1 divided by whatever you got for cosine, right? That's also going to give you the same exact answer. And then finally, cotangent of A is 1 over tangent of A. So that, in terms of A, B's, and C's, that's going to be what? B over A. So that'll be 2 over 9. And that ends up being around 0.222. Okay, and again, those are just approximations. We kind of just rounded them, but those are the correct values. Another type of problem that you're often given is you're asked to solve a right triangle. So let's do one like that. And all that means is find all the information about a right triangle. So let's say you're given this right triangle. So this is the angle theta, this is A, this is B, C, and then let's say this is angle A, angle B. Let's say you're given length of side A is 12, and then the angle A is 80 degrees, and you want to find everything else, right? So I want to find little b, I want to find angle B, and then little c. So I would start by finding angle B. We know that angle B must be 90 degrees minus angle A, right? Because they have to add up to 90. So this is going to be 90 minus 80, which is 10 degrees. Right? 90 degrees minus 80 degrees is 10 degrees. And now how do I find little a? Well, based on the information I was given to start, right, I knew, actually, no, I know little a. I want to find little b. And I also know the angle A, right, that was given as 80. So just based on the information I was given, how do we find little b? Well, how does A relate to B? Well, A is opposite angle A, B is adjacent to angle A. So I can use tangent, right? I could say that tangent of angle A must be little a divided by B. Okay, and then we can solve this for B, right? How do we solve this for B? Well, you can multiply both sides by B. B's will cancel here. And then I can divide by tan of A. Right, divide both sides by tan of A. So this cancels. I'm going to get B is equal to A over, this is a capital A, tan of angle A. So if you plug into that, right, you're going to have 12 over tan of 80. And that's equal to, be careful, make sure your calculator is in degrees, not radians, right, if your angle is in degrees. So that's going to be 2.1. So it looks like B is around 2.1 units, whatever it is. Okay, how do we find C? Well, there's a couple of ways we could find C, right? One way of finding C, I'll do it over here, is we could use, again, the information that we're given to start with. Now we basically have a ton of information, right? I also know angle B. I also know side B. So really there's many, many, many different ways. But let's just use the information we're given. So if I know angle A, 80 degrees, I know the side opposite, and I want to know C, remember C is the hypotenuse, then I could use the trig function. So what trig function relates opposite and hypotenuse? That's sine. So I could say that I know that sine of A has to be A over C. And if you solve this for C, you're going to find that C is equal to little a over sine of angle A. And if I plug in, I'm going to have 12 over sine of 80 degrees. And that turns out to be around 12.2. Okay? Or what's another way we could do it? Well, now that I have little a and little b, I could use the Pythagorean theorem, right? I know that C is going to have to be the square root of a squared plus b squared. So in this case, C would be the square root of 12 squared plus 2.1 squared. And if you work that out, you're going to get exactly the same thing, 12.2. So you could do it either way. You could use trigonometry again, or you could use the Pythagorean theorem to find C. Okay, now there's, I want to do 3 applied problems. So using trigonometry to solve applied problems. Okay, so using trigonometry to solve applied problems. Okay, so here's the first example problem. Okay, so we're told that a 21-foot ladder leans against the building so that the angle between the ground and the ladder is 85 degrees. And the question is, how high does the ladder reach up the building? Okay, so we definitely want to draw a picture here, right? So let's say this is the building. Oops. This is the building. Right, this is the ground. Here's our ladder. We know that this angle, so basically we're assuming the building is vertical, right? So this angle should be a right angle. We're told this angle is 85 degrees, and we're looking for how high it goes up the building. I'll call that maybe h. And we also know the length of the ladder. So the length of the ladder in this case is going to be a hypotenuse. So that's 21 feet. So if we extract that right triangle, right, again, I know this is 85 degrees. I'm looking for h, and I know this is 21. So relative to the angle 85 degrees, the h is the opposite side, and the 21 is the hypotenuse. So what trig function relates opposite and hypotenuse? Well, that's sine, right? So we know that sine of 85 degrees has to equal opposite h over hypotenuse, 21. So now if you multiply both sides by 21, you're going to find that h is 21 times the sine of 85 degrees. If you plug that into your calculator, you're going to find that this is 20.9 feet. So that's how high up the wall that the ladder would reach. The vertical distance up would be 20.9 feet. Okay, so in this question we're told a radio tower is located 325 feet from a building. From a window in the building, a person determines that the angle of elevation to the top of the tower is 27 degrees and that the angle of depression to the bottom of the tower is 24 degrees. And based on the information, we want to figure out how tall the tower is. So we definitely need to draw this out, right? So let's say this is the ground. This is the tower. Here's the building over here somewhere. And we know that this distance, right, if I go from here to here, that distance is 325 feet. And then we're told if we're looking out, a person looks out of some window, let's say the window is right there. Let me just draw a horizontal in here. So by the way, the length of that horizontal line, right, the dashed line is also 325, right? And we're told that if the person views the top of the tower, so if they look at the top of the tower to here, then this angle, this is called the angle of elevation, that's 27 degrees. So it's the angle above the horizontal. And then if you look at the bottom of the tower, this is not drawn exactly to scale, but something like that. Then this angle below the horizontal, it's called the angle of depression. That's, we're told, is 24 degrees. Okay, and the goal here is to figure out how tall the tower is. Let me call that like h for the height. So I want to figure out the height of the tower, h. All right, well, that's not easy to do directly. However, if you look at this, right, I sort of have a right triangle right here on top, and I have one on the bottom. So using that information, can I find this distance first? Let me call it like x, and then this distance, let's say y. And then I know that x plus y, if I add those two together, that's got to be the total height of that tower, h, right? H must equal x plus y. Okay, so, well, let's do this. We need to extract out each of those triangles. Let me start with the top triangle. So I have okay, so this is my right angle. Remember, this distance is 325 feet. We know this is x, and we also know this angle, right? This angle was 27 degrees. So relative to that angle, x is opposite, and the 325 is adjacent. What trig function relates opposite and adjacent? Well, that's tangent, right? So I know that tangent of 27 degrees has to be opposite x over adjacent. So now if I multiply both sides by 325, I'm going to find out that x is equal to 325 times the tan of 27 degrees. You can plug that into your calculator, and you're going to find that that's 165 0.6. And it has units of feet in this case. Okay, let's do the same thing for this triangle right here. We'll extract out this bottom triangle. All right, so now I have something like this. So this is my right angle. I know that this distance again is 325 feet, and this angle of depression is 24 degrees. And this is what I'm looking for, right? I'm calling it y. So again, y is opposite 24, 325 is adjacent. So again, I can use the tangent, right, trig function. So I know that tangent of 24 degrees has to equal the opposite over adjacent. So if I solve for y, right, rearrange this, solve it for y, you're going to find y is equal to 325 times tan of 24 degrees. Really all you need to do is multiply both sides by 325 to get that. And if you work that out on your calculator, you should find that this is 144.7 feet. Okay, then finally we argued, well, if I add those two together, right, if I add x and y together, that's got to be the total height of the tower. So to find h, which is what I really want, h here, it's simply going to be x plus y. So in this case, it'll be 165.6 feet plus 144.7 feet. That turns out to be 310.3 feet. So that would be my h. So we kind of had to break it up, right, into pieces. Two right triangles, we were able to find those two lanes x and y, and that allowed us to find h. Okay, let's do one more problem. Let's say we're given this figure right here. Let's say we're told this is 115. This is 56 degrees. And let's say this is 35 degrees. And we want to figure out this length here, from here to here. We're going to call that x. So the whole goal here is to find x. And this, of course, is a right angle. Okay, so how do we do that? Well, we can't easily do it directly, right? Because if you look at the triangle that contains x, it's this one right here, that's not a right triangle, right? So we can't use trig functions directly to find that length x. However, if you look closely here, I have a large right triangle, and I have this small right triangle. Well, couldn't I find this distance from here to here using that small triangle, call it maybe y. And then if I find the total distance from, say, here all the way to there, call it z, by using the large, right, the large right triangle, then I could actually argue, well, to get x now, I know that x plus y has to equal z, right? So if I subtract y from both sides, and you guys can probably see this directly, the x is simply going to be z minus y, right? So if I know y and I know z, well, I can say it's all of this minus this length y. What's left over has got to be x, right? So x must be z minus y. So we need to figure out z and y. Okay, well, we can do that. Let me look at the large triangle first. Extract out that large triangle. So this is the right angle. We know, again, this is 115. This is what, 35 degrees? And this would be z, right? Because that's the whole length on the bottom. Okay, so relative to the angle to 35 degrees, z is adjacent. The 115 is opposite. So what trig function relates those together? That's going to be tangent, right? I know that tangent of 35 degrees has to be 115 opposite over adjacent. And then if you solve this for z, so you'd have to multiply both sides by z, then divide by tan of 35, right? I'm assuming you guys can do that algebra, so I'm just going to rearrange it here. So it's going to be 115 divided by tan of 35. And if you work that out, you're going to get 164.2. So just plug that into your calculator. Be careful, make sure you're in degrees, right, and not radians. Okay, then we can look at the small triangle here. So this triangle right here, extract this one, and that will allow us to find y, right? So if I extract that one out, again, I know this is 115. I know this angle is, what is it now, 56 degrees. And I'm trying to find this length, y. So again, I know the opposite, and I'm looking for adjacent, so I have to use tangent again. So tangent of 56 degrees is going to be 115 over y. So therefore, y is going to be 115 divided by tangent of 56 degrees. And if we work that out, this turns out to be 77.6. So now that I know z and y, remember x, what I really want to find is simply going to be z minus y. So in this case, it would be 164.2 minus 77.6, and we're going to find that x is equal to 86.6, and that should be our result. Right, so if we go back to the picture, right, remember the idea here was to use the large right triangle to find z, use the smaller right triangle to find y, and we're able to use the tangent function for both of those. And then once I have z and y, if I do z minus y, that's got to be what's left over x. So that's how we found that. All right, great. So that's it for right triangle trigonometry. So next time, the next lecture, we'll look at 7.3, which is on unit circles, and basically it's going to be sine and cosine of any particular angle. So we can be in any quadrant, right? It's not just right triangle, which basically you can think of as the first quadrant. It can be any quadrant. All right, great, thanks.